To start gram staining, you need to get a slide, a bottle of distilled water, preferably, and your bacterial colonies. Then you need to heat the inoculating loop on the Bunsen burner until it turns red so you kill off all the bacteria. After heating the loop, you need to put some water onto the slide. It should be around the size of like a dime and try to spread it out as much as possible. Then you need to get some bacteria. Use the inoculating loop and open your plate up. Use the clamshell method to try to open it up as little as possible. And then spread the bacteria around in the water on the slide. Try to spread it out as much as possible. And then you want to evaporate the water out of the bacteria to kill the bacteria and fix the smear onto the slide. You also want to keep it out of the fire often, because if you don't, the slide will get heated and it might crack. And then you just do this until all of the water is gone.
Okay guys, and then you have to gram stain it. So first you need crystal iodine, which is this purple thing, and you need to flood, what's the word? I don't remember. You just need to put it all on the bacteria for 60 seconds.
Can you start my timer?
Sure. It doesn't matter too much though.
Wait, Gene.
Bro, please, just freaking evaporate. It's literally so hard.
Alright, and then you wait for a minute. And then after staining it, you have to wash it off.
We're gonna add gram iodine for like 30 seconds, I guess.
And then you have to wash off the gram iodine. And then you need to decolorize with the ethanol until it runs clear. So and then after after it runs clear, wash it off immediately. That's so immediate. Otherwise you might get like a false negative result, I think. Then you want to flood whatchamacallit? You just put saffron on it for 45 seconds.
Why does gram staining take?
Okay, so basically alright. So crystal violet goes into like the peptidoglycan, and then the grams iodine will bind to it. So in a gram-positive cell wall, there's many layers of peptidoglycan, so it can like form like a complex. And so then when you try to decolorize with ethanol, it doesn't wash off because it's like a complex. In a gram negative cell wall, there's not layers of peptidoglycan, so it gets washed off easily. And then that's what the decolorizer does, washes it off. And then the saffronin is just like a counter stain, which lets you like see the gram negative bacteria. This both of our samples are gram positive, I think. They're both like dark purple.
This is a photo of 87N. As you can see, it's very clearly dark purple, which means it's gram positive. So it has many layers of peptidoglycan, and it's basically just a way of identifying bacteria. O5M is also gram positive. It's also dark purple, which means it also has many layers of peptidoglycan, and there is no second layer of lipids on top of it. And so this is just, it's just a way that scientists can identify bacteria.